compound microscope is different from simple microscope. Its magnification is more than the magnification produced by simple microscope. In this compound microscope, we are selecting two achromatic combination of convex lens. Two achromatic combination of convex lens. Out of these two achromatic combination of a convex lens, first lens, let L1, known as objective lens. This, when we compare between both lens, objective lens and second lens called eye lens, L2, eye lens. In this both lenses see its characteristic. L1 is an objective lens. It is taken of low focal length. Low focal length related with high power P. P represent power and F for focal length. And same like it when we compare with L2 eye lens. It has high focal length. We are knowing power is reciprocal to the focal length, so it will be low power. It means that both is different. See the achromatic combination of lens. Achromatic means no chromatic aberration formed by the lenses. Achromatic combination is a lens of set of concave lens and convex lens, but final combined lens is behave as a convex lens in which the image is formed at one point, not blurred, and second thing, not enlarged, not colored, not blurred. Achromatic combination. The both problem is removed. Problem of blurred and colored image of white object. So both problem is removed by the achromatic combination of lens. And it is both the lenses lies in a tube. On one side of tube there is objective lens, and second side there is a eye lens here. So let us see first of all the ray diagram for compound microscope. Now see, this is the in tube, two lenses, L1 known as objective lens and second L2 eye lens. Two lenses are here. Let the focal point of objective lens is F O. This is the twice of FO. It is FO. FO is focal length of objective lens. See carefully. We are in the compound microscope. A small object AB we are taking at midpoint of FO and 2F. Let us make a diagram. For it, we will select two rays of light, one parallel to the principal axis, another passes from optical center. The light which is passes from the optical center is undeviated and directly fall on the second eyepiece, and the ray which is parallel to the principal axis according to the rule, we know that it always passes through the focal point. See, both the refracted ray, first ray and second ray, meets at this point. So its image is formed here of AB. It is A dash B dash. When we see the distance between these two for objective lens, this distance is represented by UO for objective lens, and this distance is called VO. And here, from distance to the focal point, it is known as focal length of objective lens. Now, see in the diagram, A dash B dash, the image formed by the objective lens play as an object for lens 2. See here, image A dash B dash play as a virtual object for eye lens. So see the same here in it. It means that this is object for the second lens O2. So we will see how the final image. Here in this we are taking a case. What is the case? That the first case, when final image is formed at capital D. We are knowing D is least distance of distinct vision. So we are keeping the second lens, that is the eye lens, in such a way that the image formed by the objective lens lies between FP and this optical center of second lens. Now see, this distance is FP, and it is F is a focal point, capital F is. Now see, when we obtain the final image at least distance of distinct vision, so to make this, understand the trick how to make a current diagram. So the trick is that first of all make final image at C least distance of distinct vision from here, from the lens L2. If final image and magnified image of the object is formed here, so take this 2 point in the scale and make a dotted line in this way. This 2, 1, 2 and this point in a scale. It will go like that. Now take this point and here in the scale and join with dotted line up to this point, and then this ray will refracted in this direction. This is the ray. Now we take this point in the scale and this ray will be refracted in this direction. So once see through this, the final image, in place of ray of light coming from here, it seems to come here. So image of A dash B dash is formed at A double dash B double dash. This is. So see in the diagram of AB object, final image is obtained at A dash B dash near to the object. At least distance of distinct vision, capital D, we are knowing for normal eye it is 25 centimeter. Magnification in this case is given by, magnification is denoted by M. The formula is angle formed by the final image on eye by angle formed by the object when it is placed at capital D. Capital D is called least distance of distinct vision. See the mean of both. Angle formed by the final image at eye. This angle is visible angle. Now see final image. See in the diagram. Final image is A double dash B double dash. Angle formed with final image. See, this is beta subtended on eye. When this is, so in the actually it is very close, and eye is close to the second lens, eye lens. So this eye is considered at this point. So angle is making beta. This is also beta angle. Now second thing. Angle formed by the object when placed at a capital D. In this case, no microscope is used. So see for that, see the diagram. Same microscopic object AB is here, and it is seen through least distance of distinct vision, capital D. So when it is viewed with the eye at here without lens, the angle subtended is alpha. So when we take beta and alpha, and when we place in the formula, magnification M can be obtained by beta by alpha. Represent as equation number 1. Now see very carefully here in the diagram. Beta we will obtain from figure 1. This is a figure 1. So to obtain beta, here we are making, because we can see the diagram here and it. Now take these 2 points here in the diagram. This point can be taken as a, suppose some point we will take X and Y. We will take 2 points. So we are going to take a triangle. Which triangle is Y A dash B dash. See here, Y A dash B dash. Beta means we will obtain tan beta, and tan beta is perpendicular by base. What is a perpendicular? A dash B dash by base is A dash Y. Represent as equation number 2 it is. This is equation number 2 from figure first. And alpha we will obtain from figure 2. Figure 2 is this. Right? Here in this, for that we will see this is alpha is equal to tan alpha perpendicular by base. Perpendicular is AB, size of object, by this is least distance of distinct vision. This is equation number 3. Now what we will do, see, beta and alpha we will place in equation number 1. So now putting the value of beta and alpha here in equation, m is equal to beta is a dash b dash by a dash y divided by alpha. Alpha is ab by capital D. So this relation can be written as a dash b dash by ab, and now D will go upper and a dash y will come down. It is equation number 4. See, magnification can be obtained by equation number 4. This equation, see carefully. A dash b dash by ab, and value of this we will obtain. Second. So for first circle, in circle a dash b dash by ab, see in the first diagram here. In this a dash b dash by ab, seen similar triangle ABX and X A dash B dash. This both is similar. Vertically opposite angle 90 degree 90 degree. So naturally this both angle will be equal. So property of similar triangle is ratio of sides are equal. In that condition it is equal to A dash B dash in place of that X A dash by X A. X A dash, this is a view by this side U naught, but this is U naught is according to the sign convention it is negative. One thing. Second, here in the formula, see carefully. D is least distance of distinct vision, but here is required to see A dash Y. So for A dash Y, see in the diagram. A dash Y. Here is A dash and here is Y. A dash Y is this. A dash Y, it is object for eye lens, see in the diagram. So it is known as UV. So we may write it is UV with negative sign, and for that the final image is formed at here Y dash YB double dash. It is on same side, so it is negative. See the sign convention very carefully. So putting this value here in magnification formula, which is represented by equation number 4, is m is equal to A dash B dash by AB in one bracket, in second bracket D by A dash Y. So in this formula we will keep the value. This implies that m is equal to A dash B dash by AB is V naught by U naught with negative sign, and it is D is a negative here, so D we will take negative, and A dash Y is minus UE. So finally magnification formula is minus V0 by U0, V naught by U naught, we may also say D by UE. This is formula for magnification when final image is formed at least distance of distinct vision. So what is required to do here afterwards to obtain the simplified formula for magnification M? VO and UO, this is UO, we will keep as it is, and value of U 1 upon UE will be obtained, and 1 upon UE is obtained by lens formula. This is 1 by F is equal to 1 upon V minus 1 upon U. This lens formula we will apply for eye lens. So see here in the diagram in the eye lens. Eye lens is achromatic combination of convex lens in which F is equal to Fe plus Fe because focal length is positive, and U is equal to minus UE, and V is minus D because it is formed least distance of distinct vision, that is the final image. That is why putting these three value here in the formula, 1 by Fe is equal to V is minus 1 upon D, and minus minus plus when we place this value 1 upon UE. So by this we may say 1 upon UE is equal to 1 upon Fe plus 1 upon D. It is represented by equation number 6. Now we will put value of 1 upon UE in equation number 5. So final formula for M magnification M is, this is minus V0 by U0 into capital D. In place of 1 by UE, it is placed 1 by Fe plus 1 by capital D. And by solving one may get M is equal to minus VO upon UO. D when we keep inside, it is D by Fe, and D is cancelled by D here, so 1 remains. This is the final formula represented by equation number 7 when the final image is formed at least distance of distinct vision capital D. This is the final formula. Now we will derive the formula for also when we see the final image with relaxed eye. So for relaxed eye the final image will be formed at infinity. So we will see for that also. So for the formula of magnification, when final image is formed at infinity, and it is formed with infinity when it is seen with the relaxed eyes. So let us see the ray diagram. Here two lenses, one is known as objective lens and eye lens is seen in a tube. Let us see the focal point here. For objective lens FO, let an object AB same as the previous kept here between F and 2F for objective lens. This distance is UO, same like as previous one. See the ray diagram. We used to take two ray, one parallel to the principal axis, second ray passing through the optical center. This point we have taken X. We are knowing it is undeviated. and falls on the second lens. This first ray, according to the rule, passes through the focus when it is proceeds in forward direction. Here crosses each other and falls on the eye lens. This is. Now see, these two refracted ray, this is second ray and it is first ray, meets at this point. So real image of the object A dash B dash AB is formed here, A dash B dash. Right? So this distance is here represented VO, and image A dash B dash is play as object for eye lens, and we want final image formed at infinity. So position of eye lens must be kept in such a way that the point A dash and focal length for eye F is coincides each other in such a way that this becomes focal length is Fe. So it means that the object for the second lens lies at a focal point of it, and we are knowing for that the final image will formed at infinite, right? So for infinite, see the trick how we'll make a correct diagram. So to make a correct diagram, take this 2 point. This point we have taken x and y. It was x and it is y in the previous diagram also. In figure number 1, join this with dotted line. Proceed both sides. This is angle beta in this case, the final image made with it. Now take another ray of light parallel to this light here with it, where it is fall. Take this is point, one single point in a scale, make a dotted line. It must be parallel to both, and from here see this is a point. This is, and see in the diagram, this refracted ray when falls on here the eye lens, refracted in this direction, proceed on this side. Second ray, first ray moves in this direction. So one whipped through here, it seems the final image is formed at infinity. Now see the whole diagram for relaxed eye here in it. So see what will be the formula for magnification in this case. The formula of magnification is m is equal to this general formula VO by U D by UE, right? It is given in equation number 5. See the equation number 5, this is. The same formula is here. Now see one change is here required. Only in place of UE, see it is UE and it is equal to FE. So it is set it in this way. So magnification formula minus VO by UE D by FE. FE we will take positive because focal length of convex lens is positive. So this is the formula to calculate the magnification produced by microscope when final image is formed at infinity. So I hope you have enjoyed with it in case of compound microscope, right? So this is for the topic Thank you and have a see this is nice day to all.